All right, so today we are continuing with our rational function section, 4.2b. And our objective today is going to be determining the behavior at vertical asymptotes. And we're going to find the other types of asymptotes, right? The horizontal or the oblique asymptotes. Okay, so first, let's go back to the vertical asymptotes. We found this last time, right? And so now we're going to find out what happens at those asymptotes. Okay, so the rules for this is that now if you have a vertical asymptote with even multiplicity, then the graph points in the same direction, and the asymptote with odd multiplicity, then they point in opposite direction. Okay, you should be writing this down in your notes. Okay, so with an example, I have f of x is equal to x plus 1 over x squared plus 4x plus 3. Again, going through these videos here, you should pause them when it's going too fast, right? Pause these examples so you can copy them down and follow along, okay? But the first thing I'm going to do is I'm going to factor things out, okay? So I have the bottom becomes x plus 1 times x plus 3. So based on the bottom, I know that I'm going to have some asymptotes and some holes, right? Because I can cross out x plus 1 with x plus 1. And remember, the one that gets crossed out, that gives you a hole. That's not an asymptote. The other one that doesn't get crossed out, that's your asymptote, right? So my asymptote is x plus 3, which is now x is equal to negative 3. And my hole is going to be x equals negative 1. See, okay, so the hole is at negative 1 based on the one that gets crossed out. And the asymptote is at negative 3, the one that is not crossed out. And the multiplicity is 1 because it's only one of it, right? There's no exponent on it. It's not happening again. It's the only factor. So multiplicity is 1, which means it's odd. So here is the graph. Now, the asymptote is at negative 3, so there's the asymptote, right? The graph approaches that, and both sides are going to go the same direction because it's multiplicity of 1. Opposite direction, I mean. Multiplicity of 1, odd multiplicity, so they go in opposite direction. So the graph might be going down this way and then up the other way. Okay, so it might look like that. One side goes up, one side goes down toward the asymptote. Okay, and there's a hole here at negative 1. See, there's a negative 1 hole, so I put a hole there. So there's a discontinuity here. The graph goes to here and it jumps, boop, and then goes over here and it keeps going. Okay, but right now I'm guessing this part, right? I only know that it's going down this way and up that way, or it might be going down this way and up this way. Okay, I don't know. But right now, all I know is that at this asymptote here, one side goes down, one side goes up because of odd multiplicity. We'll look at one more example here. I have 1 over x plus 1 squared. Now, there's nothing to factor or cancel out, right? Nothing to cancel. That means there is no hole, right? There are no holes. So we have the x plus 1 squared. That's going to be your asymptote. So x is going to be equal to negative 1 and multiplicity of 2 because of the exponent there. Okay, so in my graph, my asymptote is at negative 1. So there it is. And multiplicity of 2, that means both sides goes up or both sides goes down. I'm just going to guess. Right now, I'm going to think, oh, both sides goes up. But it could easily both sides goes down, right? And I'm also guessing the rest of the graph. I don't know what it looks like. Okay. Right now, all I know is at this asymptote, both of them either go up or both of them go down. Now let's talk about the horizontal and the oblique asymptotes. Okay, so a horizontal asymptote is the end behavior. It means that if you look all the way to the left, all the way to the right, what happens? Okay. And unlike the vertical asymptotes, where the graph cannot cross, the graph can cross a horizontal asymptote. Okay, it could cross it. Like here, it could cross this, and then it reaches it. It goes toward it as you go along all the way outside. So the graph approaches the horizontal asymptote. Okay, but it could cross somewhere in the beginning, and then it goes toward it. All right, that's what a horizontal asymptote is. Same thing with the oblique asymptote. But the oblique asymptote is not a flat horizontal line. It has a slope, right? So it could look something like this. Like here's the line. All right, that's the oblique asymptote. Again, it could be crossed. The graph could cross this, and then it could get closer and closer to it as we go along. Okay, so let's look at some rules and how to find them. Oh, all right, so let's ignore that for a second. Now let's imagine here is your function, okay, your rational function, the top and the bottom. And so here's like a x to the n, b x to the m, whatever. So we're just talking about the top and the bottom, okay? What we have is n. We're going to say n is the degree of the top, which is the largest exponent on top. M is the exponent at the bottom, the largest exponent at the bottom, the degree. A is the leading coefficient on top. B is the leading coefficient at the bottom. And here are the rules. Okay. So if you have n is less than m, that means the degree on top is smaller than the degree on the bottom. Your horizontal asymptote is at y equals 0. Okay. As long as the top is smaller, the exponent of the top is smaller than the exponent of the bottom. It's just a straight line across when y is equal to 0. If they're equal, okay, if they're both like third degree, fourth degree, then the horizontal, you have a horizontal asymptote when y is equal to a over b, which is the leading coefficient, leading coefficient, okay. And if n is 1 bigger than m, which if the top is 4 and the bottom is 3, if the top is 9, the bottom is 8, okay, then to find the oblique asymptote, you have to do long division. Okay, take top divided by bottom, and you have the equation of the line of the oblique asymptote. And if n is more than 1 bigger, so it's 2 or more than m, then you don't have an asymptote, but you have the n behavior that looks like a over b, and then the power function of the difference of the exponent. Okay, so don't worry about this too much. We'll see it when we get there. Okay, but write all this down so you can refer back to it. It's a lot of information. So here we're going to do some examples to find the horizontal oblique asymptotes. Okay, so here it is. Now you first write down all the n and m and a and b, right? So n is the degree on top, so it's going to be the second, right? N is 2, m is the degree of the bottom, m is also 2, and then a is 8, b is 4. And write that out. N is 2, m is 2, a is 8, b is 4. Now let's look back. Which one applies, right? It's going to be n is equal to m, okay? Because they're both second degree. So the horizontal asymptote is y is equal to a over b, which is a over 2, right? So y is equal to a over 2, which is 2. So my graph looks like this. I have a horizontal asymptote at y is equal to 2, so right across here. That's my horizontal asymptote. So the graph could look like it could cross, maybe it could cross in the beginning, but toward the end, in the long run, it approaches it. Okay, it could go all crazy here, but in the long run, it approaches y equals 2. Another example here. Here I have something more complicated. Let's label n, m, a, b. So n is 3, m is 5, a is 4, b is, oh man, that should be a 1. I don't know why I typed a 7 there. That number there should be a 1, guys. That 7 probably looked like a 1. I messed up there. But anyways, so n is smaller than m. Okay, n is smaller than m, so it doesn't even matter what that number is. My asymptote is that y is equal to 0. So, okay, so there is my asymptote running across y is equal to 0. So the graph approaches it as it goes on. Last example. Oof, messed up again. So here is the equation. Write this down. Now you look at your n, m, a, b, right? N is 4, m is 3. So what does that tell me to use, right? I have to use n is equal to m plus 1. If it's 1 bigger, then you use this one, right? So because 3 plus 1 is 4. So you have an oblique asymptote, and you have to do long division to find it. So here's my long division. I have that divided by that. It gives me 2x plus 1. So my oblique asymptote, oh, not horizontal, oblique. Oblique asymptote is at 2x plus 1, which is that. Okay, make sure you cross that out. Not horizontal, but oblique asymptote. There.